Water is an amazing thing. Not only is it a part of a cool, refreshing, and relaxing getaway, but it is also one of the most profound and abundant substances we have on the face of this earth. The most interesting thing about water is its countless amount of properties. Today, we will be performing an experiment that uses just a couple of these properties. The water screen experiment is an awesome example of just how versatile water really is. So relax, kick back, and watch as we learn a little bit about this unique substance that we call water. For this experiment, you will need 1 glass mason jar, 1 piece of mesh, 1 rubber band, 1 plastic bowl, 1 pitcher of water, and 1 index card. To assemble the required mechanism, place the wire mesh tightly onto the mouth of the jar and place the rubber band around it. Make sure the mesh is not loose. As you can see, the mesh has holes in it. Carefully pour the water from the pitcher into the jar until it is almost full. Then, place the note card on top of the jar and carefully flip it over. But first, let's make a hypothesis. What is going to happen to the water? It's gonna fall out into the bucket, duh! It will stay in the jar when the note card is on it, but will fall out when it is removed. It will stay in the jar. I don't know, you tell me. After I've placed the note card on the jar, I will carefully flip it over. When I remove my hand, the note card stays in place. But what about if I remove the note card? Miraculously, none of the water falls out of the jar. If I tip the jar on its side, some of the water does come out. Why do you think that is? Water is cohesive. Cohesion is an attractive force between like molecules. Since water is polar, these molecules stick together and fill in the holes in the mesh. The reason the water stays in place when the jar is turned over is because of surface tension. This surface tension allows the water to resist the force of gravity and actually stays in the jar when it is turned over. The water forms a barrier between the mesh openings using cohesive and surface tension forces. However, if I tip the jar on its side, it breaks the surface tension and some of the water comes out. What would happen if I stick the end of this bobby pin into the jar? None of the water comes out. This is because I am not breaking the surface tension or the membrane.